Now we are going to look at what happens when circles cross the x or the y axis. And quickly we're going to have a look at what it means for us to be crossing our axis in the first place. So on the x-axis, y is always going to be 0. And we can see that if we just take some coordinates of some points. So the coordinates of this point here would be -1, 0. The coordinates of this point here would be 2, 0. We can see the y coordinate is always going to end up being 0. So we say y is 0 for anything along the x-axis. And the connected point on the y-axis, x is always going to be 0. So if we look at any of the coordinates of these points here, we would have, say, 0, 2 would be the coordinates of this point here, in the door 0, up the stairs 2. Here you'd have in the door 0, down the stairs or up the stairs, -1. So we can see that the coordinates of any point we like to pick on the y-axis, x is going to be 0. So we can use that to find where our circles cross the x and y axis. So to that end, what we're going to do is say if we have this circle here, so this is a circle with this equation x squared plus y squared is equal to 9. So we can see that this has the shape of a circle centered at the origin. That's x squared plus y squared is equal to 4 squared. So we can see the radius squared here should be 9. So the radius ends up being 3, which we can see from our diagram. We start at the center 0, 0, go out 3 units all the time to the circle. So our radius would be 3. Now where does that intersect? Where does it cross the x-axis? Well, visually we can see that that is going to happen at 3, 0 and at -3, 0. That's where we're going to cross the x-axis. But we can do that algebraically. We can say, well, on the x-axis, I know that y is going to be 0. So all I have to do for my equation is say, well, on the x-axis, y is going to be equal to 0. So I say, well, my equation of my circle is x squared plus y squared is equal to 9. And I know that on the x-axis, y should be 0. So x squared plus 0 squared should be equal to 9. That's just the same as x squared is equal to 9. Now I can just take the square root of both sides. And when I take a square root, I always have to be quite careful because I have to take the positive or the negative, because either would squaring it give me 9 for x squared. So x could be equal to plus or minus 3. Square root of 9 is 3. So x could be equal to plus 3, or x could be equal to -3. And in either case, we know that y is 0. We started out with that fact. So we'd have 3, 0, or -3, 0. That's where our circle crosses the x-axis. And we can do exactly the same type of thing for where it crosses the y-axis. We just set x equal to 0, and we can see that we get 3 and -3 for our y coordinates. Now what happens if we have a circle that's not centered at the origin? We can see here we have equation of a circle that isn't centered at the origin, so we have x minus h to be squared plus y minus k to be squared is equal to r squared. So this is an equation of a circle that's not centered at the origin. Its center is going to be at h and k, so 3 and 2. If I mark that, 3, 2 is the center of that circle, and its radius is going to be the square root of 18. Well, where does it intersect or cross the y-axis? Well, when we're crossing the y-axis, we know that x is going to be equal to 0. That's what this question mathematically ends up meaning. We can see visually that that's going to happen at 0, 5 and at 0, -1. So that's what we're expecting our answers to be. Where are we going to cross the y-axis? So let's see what happens. So we just set x is equal to 0, and we try and solve our equation. So x is 0 minus 3 to be squared plus 0, not 0, my apologies, we're looking for y. Minus 2 to be squared is equal to 18. So now we're going to simplify this. So minus 3 to be squared is just going to give us minus 3 by minus 3. May as well write that down. When we put that in our calculator, we're going to get 9. And y minus 2 times y minus 2 is equal to 18. We can see that we're going to end up with a quadratic, and we're going to solve that quadratic. We have 9 plus y on y minus 2 on y minus 2 is equal to 18. 9 plus y squared minus 2y minus 2y plus 4 is equal to 18. Add up our like terms. We have y squared minus 4y plus 13 is equal to 18. And we subtract 18 from both sides in order to solve our quadratic. We get minus 5 is equal to 0. We factorize our quadratic or use the minus b formula, whichever we prefer. And in this case, we are going to end up breaking this minus 4y into minus 5y plus y minus 5 is equal to 0 if we do factorizing. And we continue. Y is our common factor. Minus 5 plus 1 on y minus 5 is equal to 0. So we end up with y minus 5 on y plus 1 is equal to 0. So y minus 5 is equal to 0, or y plus 1 is equal to 0. We rearrange y is equal to 5, or y is equal to minus 1. And we already know our value for x, it's just 0. So we have 0, 5, and 0, minus 1 are our 2 points of intersection as we found from our picture. Now we could also ask the question, where does this circle intersect the x-axis? And unfortunately this isn't quite as nice. It's we aren't crossing at nice roots down here. We're not crossing at like minus 1 or at 1 or something like that. We have a decimal involved, and that immediately makes me think that we're going to have to end up using the minus b formula when we solve this. So I'm about, not exactly, but I can see that I'm about 6.75, so very approximately from my picture. I'm thinking I'll be at about 6.75, so 6 3/4, about that. And here I'm at about minus 3/4, so minus 0.75. This is just how we can read things off a graph. We can be asked to read things off of graphs, and that's approximately where we're crossing the x-axis, very approximately. So let's see how close that is when we actually do our calculation. So on the x-axis, we know that y is equal to 0, so we're going to solve that, use that to solve our equation now. So x minus 3 to be squared plus y minus 2 to be squared is equal to 18 is our equation. So we have x minus 3 to be squared plus 0 minus 2, our y is 0 when we're crossing the x-axis, is equal to 18. We start squaring out our brackets. X minus 3 on x minus 3 is what x minus 3 to be squared means, plus minus 2 to be squared is equal to 18. So we have x on x minus 3 minus 3 on x minus 3, just multiplying out all of our brackets, plus minus 2 on minus 2 is what minus 2 squared means. So we have x squared minus 3x minus 3x plus 9 plus 4 is equal to 18. Add up our like terms. X squared minus 6x plus 13 is equal to 18. We recognize a quadratic, so we're going to get everything over to the left-hand side is equal to 0. Minus 5 is equal to 0. Now we can try and factorize this, but it ain't going to work. So we're going to have to use our minus b formula. You only have the factors of minus 1 plus 5 or plus 1 minus 5. Neither of those things add up to minus 6. So we're going to have to resort to our other tools. So we write out our formula. X is equal to, from our log tables, from our formula tables, minus b plus or minus the square root of b squared minus 4ac all over 2a. And we have this in our form. Just going to move this around a bit. And I have everything written in, so I label my quadratic so that everything equals 0. I write down my formula. I write down where a, b, and c are explicitly on the page, and then I sub in. So x is equal to minus 6 plus or minus the square root of minus 6 to be squared minus 4 on 1 on minus 5, all divided by 2 times 1. So when I tidy all of that up in my calculator, I can't put all of this into the calculator at once because plus or minus isn't a thing on my calculator. So I just have the stuff underneath the square root is what I am going to really put into my calculator, and I get 56 when I tidy it all up, all over 2. So I have x could be equal to 6 plus root 56 all over 2, or x could be equal to 6 minus root 56 all over 2. When I put those in my calculator, which I can now, I'm going to get x is equal to 6.74-ish. It's not exact, but about 6.74. And x is equal to minus 0.74. So we weren't too far off with our visual estimate from looking at the graph. So our points of intersection would be at 6.74 on the x, 0 on the y, because we're crossing the x-axis, so y is 0. And our other one is x is minus 0.74, y is 0, because we're on the x-axis. So anytime we're crossing the x-axis, we just think on the x-axis, y would be equal to 0. On the y-axis, x would be equal to 0. We sub that into our circle equation and solve the quadratic that comes out of it, and then write down our points of intersection. And that is what we need for now.